right, now what I'm going to be looking at is the second part. These are the kind of problems that you're going to be able to use a calculator on. A little shorter part of the exam, so these are kind of the main ideas from this part that I want you to be able to do with the assistance of a calculator. All right, so to begin with, of course, we learned about compound interest and the way that worked. And there's a few other things that I do want to spend a little bit of time reviewing on that are not on here too. Okay, so this one says you're going to use the compound interest formula to determine the future value of the given principal. So you've got $12,000, you're putting it at 5%, compounded quarterly for 8 years. So the first thing we want to do is write down the compound interest formula. So generally this is given like something like this. A is equal to the principal P times 1 plus, sometimes you'll have APR over N, and then N times the number of years. That may be the way our textbook does that. I oftentimes write it like A is equal to P 1 plus interest rate over N to the NT, so it both means the same thing. So really it's just a matter of plugging this in. Your principal is what you start with, so you're going to replace that in for P. Then you have your annual percentage rate, okay, and that means that you're going to have to move that decimal over to the left. Well, you got to be sure that you move that to the left too. That's a place where students often mess up. Okay, then you're going to divide by the number of times that you're compounded. So this N matches the quarterly. Quarterly, of course, means 4 times a year. Every quarter you do that. And then what we're going to end up having is we do NY. So N is 4, and then Y is the number of years, so we do 8 like that. So that's the way we would put that in. Now I'm going to just slide my calculator over here and show you how I would put this in one step. So I'm just going to go like this, 12,000 in parentheses, put it in exactly like this, 1 plus 0.05, divide by the quarterly part, close parentheses, raised to, and then you can either put 32 in or you can use a new parenthesis and get the calculator to multiply that out. Then you would round that off. So we would expect the answer to be something bigger than 12,000. So let's see what we get. Okay, so we end up getting approximately, and if we round that off, that's going to be about 17,857.57. Typically we'll round that off to the nearest cent. So then that should give the answer to the problem. So there's a few other things that I want to review as I'm going through this. Few things that you want to be sure that you study. So for instance, if your compounding was not quarterly, so if it's annually, I'll kind of make a little chart on this, then N is equal to 1. If it's semi-annually, that means that what you're going to do is you're going to do interest twice in a year. If it's quarterly, like we just saw, we'll use N equals 4. If it's monthly, you'll want to use N equals 12. And other than that, you might see daily N equals 365. Those are the typical things. Now, if we compound interest continuously, it's a different formula. It's A equals P E to the RT. That's the one I call the Pert shampoo formula for whatever reason. It just reminds me of Pert. I see the Pert in there. So that would be if you were compounded continuously, then you go to a totally different formula where you use E on that. Okay, so that's pretty straightforward, being able to use compound interest formula in that regard. Next problem to study is change of base formula that we learned about. So this allows you to find on your calculator a logarithm of any base other than 10 or e. So of course your calculator has a base 10 log, the log button, and then it has the base e log like that. So if you wanted to do a log of any number, well, you just put it in your calculator. If you want to do an ln of some number, then you just do that on your calculator. Okay, but any other base, you got to use change of base formula. So the change of base formula basically goes like this. If you have a logarithm base b of some quantity p, that's going to be equal to the base 10 logarithm of p over the base 10 logarithm of b, but that turns out to be the same as the natural logarithm of the same ratio. So you can do that either way you want to. So when we do this problem, it's very easy to do. Let's just use the log. I'll do it both ways and just show you that it's the same. So you can do it that way, or you can do ln of 25 over ln 3, and then you can round off. So notice if I go log of the number, be sure you close that parenthesis, that's real important, and then divide by log of 3, that will give the approximate answer of the problem, and then we'll round that off to 2 decimals as the problem says. So we'll say that's about 2.93. Now notice if I do the log, the natural log, if I go ln of 25 divided by ln of 3, I'm going to get exactly the same answer, so it doesn't matter which one of those things you do. Okay, so that's how that goes. Change of base formula is very simple to remember and very simple to do. Okay, next thing I want to look at is some of the things we learned about exponential equations, and we did a lot of applications of exponential equations. Okay, so this one is giving you the following information. It's given you have a half-life of plutonium 234 is 9 hours. 9 milligrams are present now. How much will be present in 5 days? Okay. Well, first of all, you got to deal with the general equation. So the general equation goes like this. A of t is equal to a naught e to the kt. All right, so if you are decaying, an exponential decay just means you start big and then your amount decays. Okay, your amount is getting smaller and smaller. Remember in this, k is a negative number. And then if you have exponential growth, remember that your function looks like that, and k is going to be positive. Now, in this particular problem, you don't know k. So you're going to have to start by finding that in order to solve this problem. But they have given you the half-life. So the way this looks is like this. If you started with any amount, a, and you can pick anything you want to for a naught, you can say 1, but the half-life, what that means is that's decaying to half its original. So you could do 1 and 1/2 to start with. That's the best way. Then you've got e, then you've got k, but then the half-life is 9 hours. So you can solve this exponential equation on your calculator to find what k is, then you can solve the rest of the problem. Okay, so you have to start this problem this way. So again, what we have is we have 1/2 is equal to really e to the 9k. This is an exponential equation, so we're going to take the natural logarithm of both sides, taking advantage of the fact that that base is e, we want to use ln, and then this is going to be ln of 1/2, which we'll leave alone for the time being. Bring down the exponent, so that's 9k times ln e. Now ln of e, remember, is equal to 1, because what this means is the log base e of e, and e to the first is equal to e. So you're going to end up with ln of 1/2 equals 9k. That thing right there is 1, so that just doesn't change anything. 1 times 9k is 9k. Okay, then what I'm going to do is I'm going to divide both sides by 9, and then what I'll have is I'll have this quantity like here. So I can have k is equal to the ln of 1/2 over 9. And I could go ahead and just take this on the calculator and round that off. I would use a lot of decimals on this if I did this, though. And you may very well get this in scientific notation. So I'm going to go ln of 1/2, or just 0.5 if you want to put it in that way, divided by 9. And you're going to get this value. So it's exponential decay. That's the reason that turned out to be a negative number. So let's write down negative 0.0770163534. I'm going to write all the decimals on that. Okay. Okay, now to finish the problem, we go back to the general formula, which is a of t, standing for the amount, is equal to a naught, that's the initial amount, e to the kt. Well, see, we now know what k is. Okay, all that work at the beginning was to find k, so we can plug that in. Now what it's going to say is how much will be present in 5 days. So that means, well, the 5 is going to go there. The amount of k, that number is going to go in there that we crunched out right here. And then it says 90 milligrams are present now. Our job is to find this. Okay, so what we're going to do to solve this problem is we're going to set it up. We'll have a to the t, or not a to the t, a of t is equal to 90 milligrams times e. K, let's just put all the decimals in, 0.0770163534. And let's multiply that by 5 days. And then basically we're just going to do this in one step on the calculator, and then we'll have an answer to the problem. Okay, so watch how I do this on the calculator. I'm going to put 90. I want e to the x to come out. E is above ln, so I can go second ln. E to a power comes out, then you're going to put in negative 770163534 times 5, and you want to get that whole entire exponent in a set of parentheses, then that will give you the amount. So that's decayed down to 61. It says round to 3 decimals, so 2355, we're going to round that up to 61.236, and this is milligrams is what you were given. So the answer is 61.236 milligrams. Okay, so that's a really nice half-life problem to know how to do. Right? You got exponential equations, the things that you have to know on this. Now, generally, I give the general formula for the exponential formula. You got to know what to do with that, though. Okay. All right, moving on. Next one is another application of this is exponential growth, actually. So it says how long, which means we got to find t. Will it take for an investment to triple in value if it's compounded continuously 4.75? So first of all, you got to know the continuous compound interest formula, which I do give you. That's the Pert shampoo formula that I like to call that. So that's e to the p. Whoops, I totally wrote that wrong on there. That's the reason I say Pert shampoo, because it helps me remember this. So it's like p is equal to e to the rt, like that. So that's the amount that you get Pert. Okay. So what you're going to do on this is it says, how long does it take for something to triple? You're going to find t. They've given you the interest. So notice on this, the interest is 4.75. Okay. Or that's, you can think of that as the growth rate. That's given. Now they don't give you the amount you start with, so it doesn't matter. You just call that 1. And then if this is going to triple, the 1 is going to go to 3. So 1 times 3 is 3, like that. So then you have this, we're going to put in 0.0475 times t. And again, be sure that when you're dealing with decimals and percentages that you move that to the left too, like that. So what you have is you have 3 is equal to e to the 0.0475 t, and then you can take a logarithm of both sides. So we're going to do the natural log of both sides. And what we're going to end up with is ln 3. And then again, remember, you can move this exponent down in front. I'm going to erase this thing right here. So we can move the exponent in front to get 0.0475 t times ln e. And then we can solve this equation for t. Okay, so remember ln of e is 1. So you've got ln of 3 is 0.0475 t. And then if you want to solve for t, then you just need to divide both sides by that quantity. So we got 0.0475, like that. And then we're solved for t, so we can use our calculator to get that final answer. Okay, so all we got to do is go ln of 3 and divide by that rate, 0.0475. And that will give you the approximate amount of time, which is going to be 23 point, and let's see, does it say how to round it? It says round to 3 decimals, so 129. Okay, so we're going to round that up to 129. So we get about 23.129. Doesn't really say, doesn't really give you anything about the amount of time or anything on that. So that should be the answer. Okay. Okay, one other thing I wanted to show you on this problem too is you can do this graphically too if you want to. This is also a good thing to know how to do. And I kind of allow you on an exam to do this either way. That you want to, you can even check this way if you want to. So one thing you could do is you could put in this basic thing here. So what you could do is you could put in e raised to the 0.0475t, but of course you'd have to use x to do that. So that's going to be an exponential growth function going like this. And then you could put 3. Okay, so what you would end up having is this kind of thing. So I'm going to go through and make the window go 0. Since our answer was 23, let's make it maybe go out to, say, 30 or something like that. Maybe scale that by 10. And the y minimum is 0 since it's an exponential growth function. And we need that to be bigger than 3, so let's maybe make that go to 4. And see if I graph this, you'll see your exponential growth function come out. And then you'll see this, and then you can find that intersection point. So if you want to go second trace, and then go down to option 5 intersect, the cursor is going to be on one curve. So you basically, if the cursor comes up on one thing like that, you can close in pretty close to the intersection point, press enter. Second cursor blinks on the other curve, so press enter. When it says guess, just press enter. And notice it's going to take you to that same value we got. Y is 3, and it's tripled in that amount of time. So you can also do that problem that way if you want to. Okay? All right, next problem is just a standard exponential equation that you solve. This one you got to solve using logarithms. So the way this goes is like this. You can take the log of both sides. You want to be sure that you have this isolated. You don't want any number in front of 4. If you did have a number in front of 4, you would have to start by dividing by 2. So you want to be kind of careful about that. So you can either do an ln or you can do a log. It's up to you. I'm going to do ln of 4 to the x plus 7 is equal to ln of 6. Like that, and it's just pretty standard solving on this. You want to be sure you got down how to solve exponential equations good, because it sure does show up a lot. So what you're going to do is, of course, use the property we've learned. You have a logarithm of a number to a power. The power comes down in front. So you're going to have x plus 7 times the ln of 4 is equal to ln of 6. Now your job is to try to get x by itself. So one thing you can do is you can divide by ln 4, and then that will leave you with the quantity x plus 7 is equal to ln 6 over ln 4. Then if you're going to solve this for x, you need to just move or subtract 7 from both sides. So if you did that, you would end up with x equals, now I'm going to subtract 7, so I'll just write negative 7 first, and then plus ln 6 over ln 4. So that is the exact answer. If I want the exact answer, that's it. Now if I want you to calculate this, then you just go to your calculator and type it in as it is. You go ln 7 plus, or I'm sorry, negative 7 plus ln of 6, and then divide by ln of 4, and let the calculator do all the work, and then just round that off. So that is going to be negative 0.571 if you round to 2 decimal places like that. Now one thing on this problem too is I never know how many students really go through and check their answer. It takes very little time to check and see if you're right on this. So if you go back to the original problem, which is 4 to the x plus 7 equals 6, and if you plug your answer in, which is negative 5.71, it's very easy to tell you're right on this problem. All you do is go 4 raised to, and then you can go parentheses, negative 5.71 plus 7. Work it out and see how close to 6 you are, okay? So notice we're very close to 6, so it looks like that's the right answer to the problem. So you want to take advantage of that. If you have time to do that on any exponential equation, you can check it, okay? All right, this problem could also be solved graphically by doing it this way. You could go through and put in the left side, which is 4 raised to the, and you got to have parentheses, 4 raised to the x plus 7, like that, and then put in 6 and y2. Now, I'm going to have to expand this window a little bit here, and I'm just going to go 0 to 10, scale of 1, and then I need to make sure that max is bigger than 6, so let's just go to like something like 8 and graph that out. So what you're going to see is you're going to see the exponential equation. I may not have made that big enough. Okay, that's the 6. I probably didn't either put that in right or something. Yeah, I got that in okay. You know what I didn't do right is I need to, that's got a left 7 transformation. So I actually probably need to do something like this. So rechange that window so you're negative 10 to 10. Now you'll see this exponential coming out. That's the exponential function. Then you'll see the y equals 6 coming out. So the intersection point should be that negative 5.71. So you can go second trace, option 5, just press 5 if you want to. And then just get the cursor fairly close. It'll eventually come down. Sometimes you have to kind of play with this cursor until you find it. So, okay, get it fairly close to the intersection point. Second cursor comes up, see on that line. Press enter. When it says guess, press enter. And now this same answer should come out like that. So that problem can be checked or even done graphically. I really like students to be able to do that both ways. Okay. All right. Now the next thing, last example I wanted to look at was just kind of looking at properties of logs. And what you've been given on this is you're given these two things or these three things, and then your job is to find the logarithm base A of 48. Now what I've given you is a log 2, a log of 4, and a log of 6. So you've got to figure out some way to express that 48 in terms of those numbers. So, and you can play with this a little bit on your calculator if you needed to. You could say, okay, 48 divided by 2 is 24, and then notice 4 times 6 is 24. So what you'll notice is if you play around with your calculator a little bit, you have 48 is 2 times 4 times 6. So we could write this as the logarithm base A of 2 times 4 times 6. Since we have a log of a product, that means we can break this up into the sum of the logs, and those things were all given to us, so then we could use our calculator to figure out what that value is. This is a real good way to test students' knowledge of basic properties of logs. So what I'm going to do now is the log of 2 was 0.693. The log of 4 was 1.386. The log of 6 was 1.792. Then I can add those numbers up to get an answer. So 0.693 plus 1.386 plus 1.792. If you put that together, I don't know why I put a parenthesis, but I need to take that off. Okay, do that, then there's your answer. Your problem is 3.871. Okay, so those are all kind of good ideas for part of an exam where you can use a calculator. The main idea on this is change of base formula, exponential equations, compound interest, continuous compound interest, something like this. Those are kind of key ideas. Okay, so that'll wrap us up on this, and hope you have a good day and study hard for the upcoming test.